Right, let's hope it works and go through. So what I'm going to start off with is numbering systems, and then from numbering systems I'm going to look further at subnetting. So I'm going to go one step into the other. If we get stuck or you don't understand something, just stop me, and then I'll try to sort it. Okay, first of all, numbering systems. Let me just put a table in here to make it a little bit easier. I'm first going to talk about the numbering system we all know, which is a decimal system. But some of the stuff may not be too obvious. So we need about, how many columns? 3 columns. And let's put about, how many rows do we take? 5 rows? 5 rows, yeah. Should be enough. Okay, so first of all, and I don't know how to do this, is 10 to the power of 0 is what? Do you remember exponentials? Is always 1, yeah? 10 to the power of 10, of 1. Yeah? Okay, let's put this in there. So, first of all, we've got 10 to the power of 0. Okay, how do we do this in Word? Does anybody know? Little exponential figure. I just put a little v, yeah? Let's assume it's not, but let's assume it's 10 to the power of whatever, for now. So 10 to the power of 0 is, and let's put this in the column below, is 1. Yeah. What have you got to the power of 0? Like 2 to the power of 0 is what? Do you remember from your math sessions? Is 1, yeah. 5 to the power of 0, 1. 2,458 to the power of 0, yeah. Michael to the power of 0. By definition, what would it be? 1, yeah? Okay, so makes sense. Okay, next one is, let me just sort of align this towards the middle, so it looks a bit more neater. Stick this in here, okay. The next one is 10 to the power of, I'm going to use this sign, not quite sure whether there's another one which we can use. 10 to the power of 1 is what? 10, yeah? 10 to the power of, 20 to the power of 1. 2048 to the power of 1. 2048, yeah. Michael to the power of 1 is Michael, yeah. So very easy, very straightforward. So anything to the power of 1 is itself, yeah. So we've got 10. Let's go to the next column. And we've got 10 to the power of 2. What would it be? 100, yeah. So it's 10 times 10. And that's 100, yeah? So let's go down here, 100. I should really put another column in, shouldn't I? So can I do this? Let's go in here, insert. It's in table, isn't it? Table, insert, columns to the left. That's the left, isn't it? Yeah. Stick another column in here, and then we're just going to go one further. So we've got 10 to the power of 3, which is 1,000, yeah? It's 10 times 10 times 10. And that's 1,000, yeah? So that's your numbering system. And you can divide, I mean, it's something you use with every day. It's a decimal system, and you can, put every number in it. So let's put a box standard number in this numbering system. What number shall we take? Something with a high number. Okay, let's do it down here. 4,789. Yeah, that's our number, and let's analyze the number. So the first statement I've got 9 ones. Yeah, straightforward. So if the next one is I've got 8 tens, 7 100s, and 4 thousands. Yeah, and so the number is 4,789. I mean, it's not a problem. You all understand this. You can all follow this. But once we go into hexadecimal or you go into binary, you think, what on earth is going on here? Yeah. But it's the same concept as what we're using for decimal. And again, the whole idea is the same thing. So we count from 0 to 10. For example, we go to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We run out of digits. What do? We go to the next column. We then choose a 1, and we place a 0 there. So and we know this value, 10, is 1 more than 9. Yeah. Again, I'm stating the obvious. If you don't know this, we've got some problems here to deal with. But I'm sure. I mean, you picked this up from being little. Nobody remember the pound and shilling system? You do.
Well, I know about it, but I've used it some more times. He was the year after global, but
He must be young. You must be young. If it's a year after, that means I must be very old because a friend of mine, he's just a few years older than me. I think he's about 6, 7 years older. He was about 7, 8 years old, or 10 years old or something. So I would have been 3. And he tried to get his hand around the dozen system. You know, what was it, like 144 shillings to a pound or something? 20 shillings to the pound, and what else? 12 pennies to the shilling, yeah, and then 200 and something to the pound or something. Really bizarre stuff, yeah. But it's the same thing where you've got some bizarre numbering system based on dozen. Okay, I'm just going to tell you one more numbering system, which might be something for the pub on Saturday. And this is the calculator you've got on your fingers, yeah. And why do you think we use a decimal system? Obvious, yeah. 10 fingers, yeah, 10 toes. 10 is a significant number in our lives because we deal with them all the time. But there's another system as well, which is a dozen system, yeah. And apparently the Phoenicians, they were using the dozen system. Phoenicians, remember, old days, Lebanon, traders, you know, big ships, trading a lot of stuff, having sacks of gold. And what they were using is, they were using the Hans as a calculator, as a mathematical calculator. Now, if you use your Hans the way Napoleon would have used them with the decimal system, you can only count up to 25. Yeah, so you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the first version. The next one is 1, 2, 3, 4, 5, 1, 5, 1, 2, 3, 4, 5, 2 5s, 1, 2, 3, 4, 5, 3 5s, 1, 2, 3, 4, 5, 4 5s, 1, 2, 3, 4, 5, 5 5s, 25. Yeah, and then you're stuck. You can't count any higher. So the Romans, who used the decimal system, were very poor, but the Phoenicians were very rich because they had a different numbering system. And what they did, they used the thumb as a pointer, and they used the fields between their fingers. Can you see them? Yeah, those fields, yeah. So, and then they started counting. So they 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 dozen. That's where the dozen system comes from. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 dozen, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3 dozen, 4 dozen, 5 dozen, 6 dozen. And so they could count up to 144. So whereas the Roman traders would have the 25 sacks of gold and then they had to send the ships back out because they couldn't count anymore, the Phoenician traders, they could count up to 144 sacks of gold. And then they had to send the ships back out again, yeah. So it's quite interesting. That's where, in very old days, where the dozen system comes from. So 10 is not the only natural number we're dealing with. But I mean, you know about 12, you know, the 12 apostles, the 12 things, 12 tribes, and all the rest of it. 12 is also a natural number, especially in the Middle East, because that's what they were using to do the calculations. Story for the pub? Okay. Okay. Okay, so the point I'm trying to make is that there are different numbering systems, and 10 is not the only one, even though it appears to be the only natural one. Okay, let's go to a different system here. And how many columns are we going to make? We're going to make about 4 columns again. Yeah, let me just go down a little bit. We're going to stick another table in here. This time's how many? Let's do 6 columns. And how many rows? Let's do 20 rows. Okay. Right, so I'm going to look at this. In this column I put the decimal value in. Here I'm going to put the hexadecimal, so you get some exposure to it as well. And here we're going to put the binary. Yeah. Okay, so first of all, we're going to start off with the same concept. We've got 2 digits, yeah, to play with. We've got 0 and 1. So our base number is 2, so everything is by the power of 2. So we've got 2 to the power of 0, which is what? 1, yeah? Let's go 1 column below. Let me just centralize everything here as well. Okay, so we've got 1 here, yeah? So it's straightforward, 1. Then here we've got 2 to the power of 1, which is 2. Yeah. Then here we've got 2 to the power of 2, and that would be 2 times 2, and that's what? 4. Yeah. And then here we've got 2 to the power of 3, and let's go one down, and it's 2 times 2 times 2, which is 8. Okay, so these are our columns, and now we're going to look at different numbers. So we're going to start off with 0, then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Yes, and then we pretty much run out of combinations. 0 is fairly straightforward, isn't it? What is 0? All the way through, yeah? And then the last one. 0 here. Okay? 1, still straightforward. Just stick a 1 in there. And just to fill up the other combinations, because with our byte we have to have something there. And in digital systems we can't have, nothing doesn't exist. It's either 0 or 1. Yeah, there's nothing in between. 2. Just a 1 here, yeah? Can you see? Because the same as in my decimal system, when I go to 9 with my decimal system, then, let me just show this. I go to 9, then I run out of figures, out of numbers, and I need to go to the next column, start with a 1, and then the next one is a 0. So it's going to be 1 more than 9. Now, if I've only got 2 figures, after I use the first one, I'm running out of figures. I'm running out of symbols, so I need to then move to the next column. And so, I mean, the problem you have with binary is you go horizontally, further and further and further for relatively small numbers, like 255, 3 digits in decimal, but we've got 8 digits in binary to express the same value. Yeah, so you can see, that it spreads out a lot more. Okay, the next one is what? We've got 3. So it's 1, 1, because we've got a 2 and we've got a 1, yeah? You're with me, you can see. And in a minute I'm going to cheat, and I'm going to make it very easy. I'm just going to go to the next one, 4. What is 4? Just here, yeah? And let's do one more properly. 5. 1, 0, 1, yeah? 1, 0, 1. Because we've got a 4 and a 1, yeah? So that gives us 5. And then we're going to just stick a 0 here as a buffer. And now, one thing you can see, do you see the pattern which is emerging? We've got 0, 1, 0, 1, 0, 1. It alternates every time, yeah? When you look at the next column, we've got 0, 0, 1, 1, 0, 0. What's going to be the next one, the next pattern? 1, 1 after that. 0, 0. 1, 1, 0, 0. And that column goes the same way all the way through. So I don't really need to bother that much. I can just fill in my little truth table and just alternate for the first column every time. Whoops, just go down. Yeah. And then in the next one, the next column, I'm just going to carry on with doubling up. So I've got 0, 0. That's wrong, isn't it? It should be 1, 1. 1, 1, and then 0, 0, 1, 1, 0, 0, 1, 1. Yeah. The next column, let's have a look at the next column down. So we start counting from here. So we've got 4 zeros. How many ones do you think we should have? 4 ones in total, yeah. So we're going to put 1, 1, and then we've got another 4 zeros. 0, 0, 0. And then we've got 4 ones going right up to the end, yeah. So 1, 1, 1, 1. Okay. So you can see the pattern emerging here, can't you? So how many zeros do you think I should have in the fourth column? 8 zeros. Can you see why? Because everything is doubling up. I've got 1 0 here, 2 zeros there, 4 zeros there. So if I follow this pattern, it should be 8 zeros in this column. Yeah. 1, 2, 3, 4, 5, 6. Okay, 2 more zeros. And then I should just have lots of ones, yeah. 8 ones, really, not lots, but 8. Okay, can you see how this works? And we can test it out as well. So for example, when we look at 13, what do we see with 13? We've got a 1, yeah, we don't have a 2. We've got a 4 and an 8. So 8 and 4 is 12, plus 1 is 13. Yeah. Easy? That's binary, yeah. So it's not really that hard, and you can sort of go this. Now the beauty is, when you look at hexadecimal, and let's start off with hexadecimal in this column here. So we start off with 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the funny stuff starts, where we have got A, B, C, D, E, F. And so when you look at a byte, you can actually take this truth table and you can make up a hexadecimal number from a byte. So you just look at the bit pattern, and then you work it out what it is in hexadecimal. Yeah. So for example, if we let's put a random byte. Yeah. Okay, what shall we take? We take 1, 0, 1. Yeah. So what we can look at is we've got 0, 1, 1, 0. So we look at 0, 1, 1, 0, which is 6. So it's going to be 6. And then we've got 1, 1, 1, 0. And 1, 1, 1, 0 is 14, which is E. So we've got 6E, and that's my byte in hexadecimal. So it's very easy to convert. All I need to do is just make up this little truth table, and then I can just swap from binary into hexadecimal instantly. Yeah. Any questions so far? Are you okay so far? Anybody sort of wondering what I'm doing here? So far it's not magic, isn't it? Yes, it's magic. Or oh, okay. It's okay. Right. The next bit, what if I sort of try to look at this byte in, I know so far in hexadecimal is 6E, if I try to analyze this byte in hexadecimal, what value have I got here? I've got 1 here, 2 there, 4 there, 8 there. What's the next one? Yeah. Yeah, okay. So if I want to convert this byte into decimal, so I look now, all I need to do is just sum up what I've got. Let's start from this side here. The highest value is 1 to 8. Yeah? So if I've got a 1 there, it means 1 to 8. I haven't got a 1 to 8. What have I got? I've got 64. What's the next one? 32. Have I got a 16? I don't worry about it. Have I got an 8? So I've got an 8. What else have I got? A 4 and a 2. Yeah. And all I need to do is just add it all together. So 64 plus 32 is 96. Yeah. Plus 8, 4. Yeah. 108, and that's 110. Yeah. Okay. So if I add them all together, I've got 110. So in decimal. And so 6E should be the same as 110. Let's look at a calculator, scientific calculator. So I'm just going to type in calc. By the way, if you want to turn it to scientific, you go to view. I think scientific doesn't do it anymore. In XP, you get the scientific calculator, and it'll go between all the different numbering systems. In Windows 7, I didn't know this till this afternoon. Never really noticed. You have to go into view and then into programmer. Yeah, and then down here, you get all the different numbering systems. So if I put in 1, 1, 0 in decimal, and then I type to hexadecimal, I should get 6E. Yeah, and can you see 6E is what we found out with our truth table, without great deal of computation. And if I go into binary, I should get the same figure. Yeah. It hasn't put the 0 at the front of it, but I've got 7 digits here. But if I buffer it with a 0 right at the front, yeah, you've got it. So we've got 0, 1, 1, 0, and then 1, 1, 1, 0. Yeah. So if you're ever struggling or you're trying to figure out, especially if you have to go from hexadecimal or from decimal into binary, use your calculator. I mean, you'll always have a computer with you, or magic mobile phones, and like the iPhones and stuff like that. And there's a calculator on there. It's a scientific one as well on the Android ones. Does anybody know? I've never tried it out. There might be an app you can download. I mean, I don't know whether you would want to. I've got a scientific calculator on my iPhone or my Android. Yeah. I bet you haven't got one. Is there one on? Or? Just a basic calculator. You can't go between numbering systems. Yeah. I mean, the easiest way really is to go from hexadecimal. If you see hexadecimal, it's probably the easiest way. Go to binary, and then from binary, just do the same calculation and see so many 1 to 8, so many 64, so many 32, so many 16s. Add them all together, and then you've got your value. Okay. What next? You okay so far? I haven't lost you yet, have I? So? You okay? Mm. Yeah? Yeah, okay. Right, okay. So far we've got our IP addresses, and we find the basic for our IP addresses. So we know it's all done in binary. And really what you need to look at is binary. You have to look into binary when you look between subnetting and between different networks. Okay, let's look at some IP addresses, and then we're going to do the calculation into binary, and then we'll move one step forward. I'm just going to take a typical IP address. So we've got 192.168.10, and then I'm just going to put anything in here, 9. Yeah, so that's our IP address, and at the moment is /24. Yeah, so I'm just going to put the subnet mask underneath so you can see this. So it's 255, 255. 255. Let me just spread it out a bit so that it ties up with the subnet mask. And then right on here we've got 0. Yeah. So you can see fairly straightforward IP address, and it's nothing too much to worry about. So if I were to sort of identify this as network and host, I'm going to put a network over this octet, network over that one, network over that one, and let me just, and then host over this one. Yeah. Are you still okay with the network host? What is the important thing about the host portion? What's rule number 1 with the host portion? Can I have -2, yeah? So for example, if you calculate the range of the IP addresses you've got available for the host, you take the number of bits you've got to the power of 2. So, or it's 2 to the power of the number of bits for for your network portion, and then you have to subtract 2 addresses, because the lowest one, all 0, is network, and all 1s is broadcast. Okay, so we've done that. What about the network portion? What has got to be the same for every computer, the same network? I pretty much gave you the answer there. Yeah, for every host on the same network, the stuff in the network portion has got to be identical. I'm talking binary here. Whatever you see in binary has got to be the same for every computer in the host portion. Okay, let's sort of turn this into binary, and then we're going to slowly go into subnetting. Okay, 192 is what in binary? I feel like a genius now, but I do it so often, so I just know this. 168 is what? It's 192. Sorry, 128. Yeah. What else have we got? We have got a 32. Yes, we have. Yeah, it's 160. Then we've got 2 zeros, and then we've got an 8. Yeah. So that's 168. Now 10 is again fairly straightforward.
168. That's 128 and 65.
Oh, yeah, sorry. Yes, well spotted. Many apologies. 128 plus 32 plus 8, yeah. So we've got it. Okay, the next one is 10, which is 8 plus 2. And then the last one we have got 9, which is 8 plus 1. Yeah, straightforward. Okay, my subnet mask so far is 111. One too many. Stick some ones in here. And then we've got a bunch of zeros. Yeah. What is the job of the subnet mask? In your own words. Yeah, how does it do it? Through unding. Yeah, okay. Do you know what unding is? Do you remember? 2 doors. Both have to be open for it to go through. So it just filters out whatever bits you've got across the network portion. Okay. Right. What I want to do now is, we've got this, I'm just going to highlight this. We've got this portion here which is not used at all. Yeah. So the idea might be, we might decide, okay, we've got this marvelous network here, yeah, but we don't trust those people in accounts. Yeah. We are doing production here, and we think they're just taking all the good stuff, you know, all the good designs, and sell them off to the competitors. So we don't trust these guys. We want to separate the network so that they can't access our computers, or we can control the access. So they decide, we're going to do some subnetting. So what would I have to do first to do some subnetting, to extend my network portion?
Work out how many hosts you need in your own network.
That's the first thing. That's very important. So let's say we need, first of all, 2 things really. I need to know how many networks do I need, and then I need to know how many hosts do I need. Let's say we need about 4 different networks, and we need at least 16 hosts. Is it possible? Okay, how many bits do I need to generate 4 different networks?
3.
Yeah, 2 to the power of 3 is what? Is 4. Yeah, no, it's more, isn't it? It's 8. 8, yeah. 4 different networks. Maybe it's a little bit confusing. I should probably say we need 5 networks. Why did you say 3 bits? Why did you say we need 8? It's the nearest one, which... There's a reason for that, and it depends what book you're reading. Yeah. Okay, I'm just going to take it away, sort of anticipate it. Now, Cisco used to say that convention is that you shouldn't use the first and the last subnet. Yeah. So that means in your subnet portion, you should, same as with your host portion, you shouldn't set everything to 1, and you shouldn't set everything to 0. Yeah. Convention, only convention. So if you ever run out of networks, you can actually choose everything to set. You can actually set everything in your subnet portion to 0, and you can set it to 1, and it'll still work. It won't work in the host portion. So the host portion, you don't have any choice. If you run out of hosts, you have to go to a different IP addressing scheme. So everything 0 in the host portion, again, it's broadcast. Everything 0 is network. Everything 1 is broadcast, and you can't get away from that. The system won't let you use it. Whereas in the subnet portion, it's possible to set everything to 0, set everything to 1. Okay, so the first thing we're going to do is, we said we need 3 bits, yeah? So we're going to set 3 bits to 1 in our subnet mask. Okay, let me just push this a bit forward. Smart, isn't it? So now my division line between network and host is, if you can see the cursor here, is just between those 2 here. Yeah, so all here is host, all on the other side is network. You okay with that so far? And the problem is nothing makes sense anymore. So when you look at decimal numbers, you can't really tell which, unless you really know your subnetting very well, which 2 IP addresses are on the same network and which are not. Yeah. And let's go through this scenario here. So let me just highlight the network portion. It's playing up here. Why does it play up? Let's go from the other side. Okay. So the yellow stuff is now my network, yeah, and the white stuff is my host portion. Yeah? And I've extended my network from there 3 bits into this line here. Okay, so let's do a calculation and see how many what my address range is. Yeah. The first network, convention says, and it depends which book you're reading. Some books say the first subnet IP address is everything set to 0 in the subnet. Some books say you need to set it to 1, the first one. So if I start counting from my subnet, this is my. Let me just highlight this. Yeah, this is my first subnet network address. Yeah, which I'm using. And then the rest is my host portion. Okay. So I now do a calculation where I put down which is my network address, and then my first host, last host, and then I've got the broadcast address as well. Should be just put the address as well. Okay, let's see what we get. So we've got 192.168.10, so nothing changes here. But then something starts changing here. So if I use this as my first address, what figure is this here? That's 32, yeah? So first of all, I can start with 192.168.10, and then I've got 32. And if it's my network address, I have to set everything in the host portion to 0, yeah? So it's 32. And then my subnet mask is changing as well. What is my subnet mask now? It's not 24, it's 27. Yeah? If I'm losing you, you need to stop me. Again, 27. If I count all these bits here, so I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27. Are you with me? So I'm just counting the number of bits in my subnet mask, and that gives me my 27. Now, if I get a funny number here, I know straight away subnetting is taking place, and I have to be very vigilant to try and find out what's really going on here. So my first usable IP address, so I stick this one to 1, yeah? So that's my first host I can use, maybe my router or my access point, depending what I want to use it for. Okay, so far straightforward. What's it going to be when you read this IP address? Yeah, easy. Yeah, it's just 32 plus 1, so it's 192.168.10.33. So put this down: 192.168.10.33. Yeah, and again, just to avoid any confusion, /27 for the subnet mask. Okay, now I'm going to go and I'm going to try and look for the last IP address. So in my host portion, I have to set everything to 1 apart from the last bit, the lowest bit. And that's the last possible IP address I can use. And if I increment by 1 more, it becomes a broadcast address. Okay, let's do this. So we've got a 1 here, and then we've got 3 ones there, and a 0. Okay. So what would it be? Okay, let's quickly have a look. So if I set everything to 1, what's this one here? That one is 64, yeah? So everything set to 1 here must be 63, because that digit down there is 64. So if I take 1 away, it's going to be 62. Yeah? So that's the easy way to sort of try and work it out without being a genius. Okay, so I've got 62. And then obviously the broadcast address, all I do is I set this one to 1. The next increment, I would have to go to this bit here, and that would become a 1 and the rest 0, so it would be 64. So it must be 63. Or the easy way to look at it is you just increment by 1, hence it's got to be 63. 63 /27. Okay, do you see what's going on here? Yeah, and the nasty thing is, for example, if I give you an IP address, for example 192, and this is where people sort of stumble over all the time, and you find when you do the exam questions, You get these examples all the time. So if I put in 10, and then, for example, I put in, what shall I put in? 26, yeah. And then you put /27. Unless you really go into binary, you wouldn't have a clue that this IP address is on a totally different network to this IP address here. Yeah. Let's quickly go into binary just to illustrate this, and then you can see where the difference is. I'm going to stick the IP address up here, so the first bits are the same, yeah. And what have we got? 1, 0, 1, 0, yeah. So far everything is no problem, and then we're going to hit the 4th octet, and that's where the problem starts. What is 27? We don't have a 1 to 8, we don't have a 64, we don't have a 32, that's right. But we've got a 16. What else have we got? 16 plus, what is 27? My brain is going, plus 9, huh? 16 plus 8. Oh, it's 26, isn't it? It's not 27. So 16 plus 8, 26. So we've got an 8, and then we've got, what do we need? A 2, yeah? Is this right? Okay. I trust you. But can you see, when you look at the network portion, let me just sort of try and match it up a bit better. When you look at the network portion, it doesn't add up. Yeah. We've got a 1 here in the network portion. We've got a 0 there in the network portion. Yeah. Using /27. So both IP addresses are on different networks. So that means if he wants to talk to this guy here, they need a router in between. They can't do this. If they're on the same local area network, they cannot communicate unless there's a router between them. Yeah. So then question number 1 is, can you see the problem? Who can't see the problem? Who doesn't want to see the problem? And then the next question is, do you see where the issues are and where the problems and why it's important to get your head around subnetting? I always say to people, what you need to do is when you do subnetting, you have to go into binary. If you go into binary, it's ever so easy. You just compare patterns. You look which is your network portion. Are all the bits the same? Are they not the same? If they're not the same, you're on different networks and you need to choose a different IP address. Okay? No? Right. Are you ready to do it yourself? Have you got paper and stuff like that? Okay. I'm going to give you a task. Yeah. Let's challenge you a little bit. So we're going to use a class B IP address, private class B. And I just give you a network address. Create, how many subnets do you want? 20 subnets, yeah. Space for 20 subnets. Okay, let me just... Space for 20 subnets, and then maximize for hosts. Otherwise, it's a bit tricky, because what you could do is you could say, oh, I just take the whole octet, yeah. So I've got 255, 255, yeah. And then you just say, I need 20 more subnets, no problem. So I put another 255 in there, and you've got 256 subnets, yeah, possible subnets, or 254, if you follow convention. But if you have to maximize for hosts, then you have to see, how many bits do I need to borrow to get 20 subnets? Let's get this out of the way. How many bits do you need to borrow? How many subnets can you get with 4 bits? With 4 bits? Think about the table. 4 is 16, okay. 5 bits? 32, yeah. So you need to borrow 5 bits from the host portion. And what else do you need to do? You have to host portion. Okay, maximize for hosts and calculate the range. and this is a bit of a challenge if you can get it, for the second subnet. Not the zero subnet, not the first, but the second subnet. Yeah, see what you come up with. Have you got all pen and paper, or you okay? No? Pen and paper. You okay, You okay, guys? So if you want some paper, some here. I'm gonna get some pens as well. And it should start now. Okay. Right, let's give it a go and see what we can do. So we've got 172.16. We want the second subnet. So the best thing we can do is to turn everything straight away into binary. So let's give it a go. So I'm gonna take 172. 172 is we've got a 128. We've got a 32. What else have we got? We've got 128, 32 is 160. We've got a 12, yeah. So we've got an 8 and a 4. Then we've got 16, which is 0, 0, 0, 0, 0, 1. Then a bunch of zeros. And then at the moment, we've just got a bunch of zeros, yeah, for our host portion. Just let me... And, okay, our subnet mask for now is just 8 ones. 16 ones. And then we've got a bunch of zeros. Okay, let me just highlight the network portion. Okay, so that's highlighted. And that's what we're dealing with so far. And as I said before, you always have to go into binary to sort of try and make life easy on you. So the first calculation we need to do is we have to find 20 subnets. Yeah. So to do this, we use a formula, which is 2 to the power of, I'm just going to write it out, 2 to the power of, what did we say, 5? And that equals 32. Yeah. So it's 20 or more. 2 to the power of 4 is 16. So 2 times 2 times 2 times 2 is 16. So it's not enough. Yeah, I need a few more networks. It also tells me to maximize for hosts, so I have to leave as much space as possible for the hosts. By the way, I think your calculation was right. I've just done it over there, and it came up with the same figures you came up the first time round. No. I probably confused you. I'm really, really sorry if I did. But anyway, you'd see in a minute. Come say. Sorry? We've got some sellotape next door, so you can put it back together. Okay, so that means we need to borrow 5 bits from the host portion. Okay, 5 bits. So we're going to do this right here. So we're going to take 1. Let me just take this away. So it's 1, 1, 1. Space them out a bit. And then we've got another one here. Okay, so we borrow 5 bits from the host portion, which means that my network portion is going to be extended by 5 bits. Doesn't do it. Okay, so we're going to highlight this as well. So that's now my network portion. Can you see it's grown? It's grown by 5 bits. Okay, what is the next job I need to do? They want me to calculate the whole range for my network portion. And we've got another thing here, which is a second subnet. So the second subnet, how do I find this out? So first of all, 2 in binary is 1, 0. Yeah, you agree. That's what we found with our truth table. So if I go up to our truth table, it's still up here somewhere, and I look at 2. 2 in decimal is 1, 0 in binary. Can you see? Okay. Right, let's go down again. So what I need to do now is, that's not the right expression. What I need to do now is I need to put in 1, 0 from the point where my network portion starts. So that would be this figure here. So I've got my 1, 0 here. I'm just going to highlight it. It doesn't quite work, doesn't it? I always do something else. Try again. No, again. If I do it the other way. It's just crazy, isn't it? Anyway, just follow the mouse. Those 2 figures, they are my 2 in decimal, or 1, 0 in binary, and that's the second network. The second network I'm looking for, and where I'm calculating the range for. Okay, so let's do the calculations. We start off with the network address. Then we want the first host address. Then we want the last host address. And then we want the broadcast address. So we've got the complete address range, so we know what we can use and what we can't use. Okay, the first host address, we've already got it here. So we've got, let's do a calculation, 172. And then the next one is 16, so nothing has changed in my first octets. But something has changed in the third octet. So what have I got? I've got 16 again, yeah? That's, I think, what you got, yeah? So I've got 16, and then because it's my network address, everything else in my host portion is set to 0. Can you see? In this portion here, it's got to be set to 0. So it's just going to be 0. And then obviously I need to indicate the subnet mask I'm using. And my subnet mask now is not 16, but I have to add 5 bits, which are those bits here. And those 5 have to be added, so 16 plus 5 is 21. Yeah. So my subnet mask is 21 bits. Okay, for my first host, all I need to do is I'm going to turn this into 1. And so that might be the address for my router, for example, or my access point. So I've got 172.16.1/21. Yes? Easy? No? You're getting it. It's once you get sort of into it, it's not that hard. But what you find is next week when you come back, you think, what was it all about? You know, I had this nightmare of subnets coming and going and so on. But anyway, you need to do it a couple of times, and then you'll get the gist of it. Okay, the last one is so I'm going to set everything to 1 other than the last bit. So I've got 1, 1, 1. Yeah, and then 1, 1, 1. Let me just sort of try and push it a bit across so it ties up with the subnet mask below. And then we've got 1, 1, 1, and the last one is a 0. Yeah, so again, the next one looks really wild. So we've got 172.16, and then the next octet is way out. Yeah. So I've got 16 here, and then I've got 3 ones here, which is, what is it? 7? 16 plus 7 is what? 20? 23, okay. my brain is getting tired, so I'm sort of pretending I'm trying to get your attention, but really I don't know. Okay, and then we've got 2, 5, 4, yeah? /21. And you see straight away, it looks really weird because we've got 16, we've got 23 there. Both of them are still on the same network. And when you look at it in classful IP addressing, it just doesn't make sense at all, yeah? But because we are doing some subnetting and we're applying some magic here, it makes perfect sense. Now the last one is, this is a broadcast address which I can't use. So I have to set everything to 1. And 172.16.23.255 /21. So that's my broadcast address. Did you get the same or something else?
Is that the second network?
Sorry?
Is that in the second network?
No. That's a broadcast address. It's still it's excluded. So the second network would look like this. So if you move one higher, so we've got set everything to 1 here. So for example, if you set this one to 1, where you see the cursor, and then the rest to 0, that would be the second network. And if you set that one to 1, that would be an 8, and that would be 16. So it's 24. Yeah. So the network address for the next, for the third network, is it the third network?
That's what I'm saying. That
It is, yeah.
second network, yeah?
That's, yeah, sorry, yeah, you're right. The third network would start, let's do the third network so you can see.
This network is not.
Third network, yeah. So the network address would be 172, and this is by just incrementing this by 1, this value by 1. If we do this, we add 1 more, then we are in the next network in the network address. So we've got 16.24.0, yeah, minus 21, and that would be the third network. And when you look at it, it makes sense as well, because if I increment this expression by 1 more, that digit here would set to 1, and the rest would set to 0, and then I'm in the next network.
If I'm wrong, but you said that when you create 20 subnets, and that, well, your first subnet was /16, your second subnet was /21. First subnet.
No, it's not the first subnet. Okay, let's just to clarify this, we've got about how much have we left? We've got about 10 minutes left, okay, and then 10. So I can't really start another exercise, but let's do the third network and do the first network. Do the calculation for both of them, and then you can see how this all fits together, and hopefully, something will click. So the 16 is not the first network; it's a completely different network. Yeah, we have subnetted, and then within our subnets, we can calculate range of networks. So we can have the first, the second, the third, the fourth, fifth, and so on, all the way up to 32 networks if you include the network 0 and networks 32 as well. Yeah, or 31, 0 and 31. Are you with me? Okay, let's do the third one just to finish it off, and then we can see this how this works. The easiest way is I'm just gonna do a copy and paste. Yeah, so I'm gonna copy this, and then you can do the third network. Okay, I'm just going to paste this down here, and we're going to change the figures slightly. Yeah. So for the third network, this has to become a 1. Yeah, and can you see 1 is what in denary? 3. Yeah. So it must be our third network. All the rest here has to become 0, 0. Let's do it properly, and then you can see how this all fits together. And then we've got 8 zeros here. Okay, so we've got 24, 0, and then when I go to the first host address, /24, yeah, and fairly straightforward 1/21, yeah. Again, the first host, all I need to do is I set this to 1, the last bit to 1. Are you okay so far? Do you see what I'm doing here? Yeah. Then the the next one is the last host. What do I need to do for the last host? Sorry? Other than the last one. Yeah, okay. Let's do it, okay? So we're gonna put 1, 1, 1, and then we've got 7 ones and a 0, yeah? So it's 1, 1, 1. Let me just tie it up with the subnet mask a bit better. And then 1, 1, 0, yeah? What do we get? Here we've got a bunch of ones here, so the next one, this digit would be 32, yeah? So that has got to be 31. So we've got 172, and again we get like a weird number. So 172.16.31.254 / 21. Yeah? You agree? Okay. And then we've got the broadcast address. We're just going to set the last bit to 1. And then we've got 172.16.31.255 / 21. You okay with that so far? You want to, 5 minutes, have a go for the first address, see whether you can get the first subnet yourself, and then we'll do it in 5 minutes on here. Just give it a go, see how far you get. The first subnet. We've done the second, the third, just do the first subnet. Right, just as the last exercise today, turn this for the first subnet. Again, what I'm going to do is I'm just going to copy. Can I copy this? Try again. Copy this binary expression, and then we're just going to modify it to make it fit for the first subnet. Okay, let's go down here. Okay, so we've got this in binary, and let's turn it all to the network address so far, and then do the changes we need to go for the first subnet. Okay. First of all, the network address, yeah? This is my subnet portion here. You can see with the mouse or the cursor, and so far this was calculated for the first subnet. In binary, what is 1? 1 is 1, yeah? So you don't have to do a great deal. So we're just going to change this back to 0. And my subnet starts at this point here. The first subnet would be simply 1. Yeah, fairly straightforward and easy. Okay, right away I've got my network address, which is going to be, just write it down. So it's network is 172.16, and what is this? 8, yeah? 8, and then 0 / 21. Okay, are you with me? So did you get the same for the fourth subnet? Okay, good. Right, the first host, fairly simple as well. So first host. So we've got 172, and all we need to do here is, just turn this into a 1 in binary. Then we've got 172.16, 8, and 1 / 21. Yeah, straightforward. And then to get our last host, in binary, all we need to do is turn everything to 1 other than the last bit. So it's 1, 1, 1, 1, and then 1, 1, and the last one is a 0. Yeah. So we've got 172.16. And it's no longer 8, but what have we got? 15. Yeah. 15.254 /21. And then the broadcast address. Fairly easy. All we need to do is just change the last bit to 1, and then everything in my host portion is set to 1, which means it's broadcasting. And we've got 172, 16, 15, and then 255 /21. Did you get this? It's one of those things. It's a bit like driving a bicycle. Once you get it, it's not a problem. You're not going to fall down. The first couple of times you think you get it, you still fall down once or twice, but then eventually it's not an issue. Yeah. And the challenge is, and it's what you find in the exam questions is you get a scenario that you've got a gateway. You've got a couple of computers, they all have got IP addresses, and they all get this funny, they don't get 16 or 24 or 8 as a subnet mask, but they get a funny number, like 17, 18, 20, 22, 21, 30, or whatever. And you can't really tell, looking at the decimal value, which is in what network, and the only way to really find out what's going on is turn this into binary, and then look at the bit pattern. Everything in the network portion has got to be the same. And if it's not the same, then they're on different networks. And then maybe the default gateway is out, or maybe a host is out, or something like that. And you need to identify this on the exam question. And it's like for this as well as for the real Cisco exam. So there might be some stuff coming up as well, to do with IP addressing and something has gone wrong. Any questions so far?
Can you write the subnet mask itself? Is it 255?
Yeah. Actually, it's a good point. We really should do this. I've forgotten this. Subnet mask. Okay, the subnet mask for 21, yeah? When you look here, we've got 255, 255. And when you add this up, we get 248. I just know what they are. And I'm just going to give you the list of all the different subnet masks you're likely to come across. So we've got 255. And let's do this as a last thing today, and then we're going to finish. 248. And 0, yeah. The likely subnet mask you're to come across depends on the following. So if I borrow 1 bit, I get what? What's my subnet mask? 1 bit from the host portion. Think about it. So if you move into the host portion, you just borrow 1 bit here. It's 1 to 8, yeah? 1 to 8. Okay, you borrow 2 bits. What do you get? 196, yeah? This is right, yeah. 196? 192, yeah? You borrow 3 bits. 224. 4 bits. 240. 5 bits, which we've just had here, so it's 248. 6 bits. 252. 7 bits. 254, and you can also borrow 8 bits, yeah? So for example, if you've got a class B IP address, you can borrow 8 bits, and then you've got a complete octet, which you network or subnet. So if you borrow 8 bits, would be 255, which is fairly easy, then all the numbers make sense again. Yeah. So these are the possible subnet masks you can see. Anything else in between there doesn't work. It's just not right. So it's either 128, 192, 224, 240, 248, 252, 254, 255. Yeah. They're the weird numbers you're likely to come across. Thank you for the question. That was, I forgot about this. It's quite important as well, because when you do the practical exam, there'll be a question about calculating subnets and designing your own subnet. And one of the things you have to come up with is a subnet mask as well. You need to say the subnet mask. Yeah. Any more questions? Or can you sleep tonight or not? You will be thinking about the 4th subnet, the secret, the mystery. Okay, I'm gonna leave it at that.